Welcome to all info. Today we will discuss the topic that is solution. We know mixture is a combination of two or more substances. It may be homogeneous or heterogeneous. If you see these two type of slides, first slides, the solution color is visible and the particles are visible, but second slides is transparent, the particles are not visible. First slide it has separation, but second slide has no separation. That means first slide is a heterogeneous solution, heterogeneous mixture, but second one is a homogeneous mixture. Solution is a mixture of two or more components. These two components are solute and solvent. Solution is a mixture of solute and solvent. Solute is present in less amount and solvent is present in higher amount. So in the solution, solvent takes higher percentage and solute takes lower percentage. Then for example, this is a copper sulfate solution where the copper sulfate is a solute and water is a solvent, and the copper sulfate solution is a mixture and it is also called a solution. Types of solution on the basis of amount of solute. That means we are classifying the solution on the basis of the amount of solute present in the given solution. Amount means the percentage. So here types of solution, for example, that is unsaturated, saturated and supersaturated solution. Unsaturated means more solute can be dissolved. If you add more solute, it can be dissolved. That is called unsaturated solution. If no more solute will be dissolved, that is called saturated solution. If no more solute will be dissolved, that is called saturated solution. If excess amount of solute is dissolved when saturated solution will be heated, that is called supersaturated solution. So if less amount of solute is present, that is called unsaturated, and if as per the solvent the exact amount of solute is added, that is called saturated solution, where no more solute will be added or no more solute can be dissolved. But supersaturated means when the same saturated solution where solute is not dissolved, when the solution will be heated, then it will be converted to supersaturated, so that more solute can be dissolved. If you compare, you see the graphically, when it is the amount of solute per 100 gram solvent in the x-axis, and this is the temperature. We know when temperature increases, the solubility increases. That means the amount of solute increases. If you see that here, this graph indicates that is saturated solution where the amount of solute is exactly same as the amount of solvent present. That means that much of solute required for the given amount of solvent already added. That is called saturated solution. But under the graph it is unsaturated. Unsaturated means here the unsaturated means the amount of solute is less. Supersaturated means amount of solute is more. So on the basis of graphically we can also distinguish unsaturated, saturated and supersaturated solution. That means supersaturated solution has a higher percentage of solute compared to other two. Then what is the concentration of solution? Concentration of solution means amount of solute present in a given amount or given volume of solution, that is called supersaturated solution. How much amount of solute is present in a given volume or given volume of or given mass of solvent or mass of solution, that is called concentration. It is also called solubility. Solubility also is called as concentration. For example, here it can express like this: amount of solute to the amount of solution into 100. That means mass of solute to the mass of solution into 100. or mass of solute to the mass of solvent in 100. With respect to solvent also you can calculate, with respect to solution you can calculate. Then volume of solute or volume of solution. You can express volume of solute to the volume of solution. Also you can take volume ratio, mass ratio and mass to volume ratio. A different way you can express, but the concentration solution. Concentration of solution means the amount of solute present in given mass or given volume of solution. That is called concentration. Okay. Types of solution on the basis of particle size. Previously we discussed the types of solution. That types of solution on the basis of amount of solute. Here the types of solution on the basis of particle size. Particle size, that means here you see generally three types, that is true solution, then suspensions, and another is colloidal solution. True solution, suspension and colloidal solution. You see the slides. Here the last slide is very small particle size, that is called true solution, and middle has largest size, that is suspension, and first one is medium size, that is colloidal. You see, so first one is colloidal solution, second one is suspension, and last one is true. True particles means particle size very small compared to other colloids and suspension. Colloid size is in between true solution and suspension, means less than, greater than true particles and less than suspension. Okay, this is the types of solution on the basis of particle size. What is true solutions? True solutions are homogeneous, mainly all are uniformly mixed, no separation. Then all are same phase, no separation is there, all are in same, all are not visible separately. Then particle size very less, that is less than 10 to the power minus 9 meter, very small size, 10 to the minus 9 meter. Then it cannot be seen naked eye, that means you can't see the particle in the solution, not visible to naked eye. Then solute cannot be separated by filtration. Ordinary filtration method is not possible to separate the solute from solvent, so not possible. And solution is quite stable nature. If you keep the solution for more time, there will be no separation between solute and solvent. That's why it is very stable. Then example of true solution are already know, that is acid solution, base solution, that salt solution. These are the, and other examples are air, salt solution, sugar solution, all are homogeneous. As they are homogeneous, that's why these are called true solution. Sugar solution, salt solution, acid solution, base solution, air, salt solution, all are examples of true solution where the particle size is very less and it is homogeneous nature. Then suspension. Suspension is heterogeneous. Already I have shown you, that is heterogeneous means particle is visible and there is a separation between solute and solvent. And all are different phase means separation is there. Particles are visible. Particle size is very larger. That is how much? Greater than 10 to the power minus 7 meter. That is particle size is greater than 10 to the power minus 7 meter. Then particles can be seen in naked eye. Because particle size larger size, it is visible to naked eye. Then particles can be separated by filtration. As particle size larger size can be easily separated and can be done by filtration method due to large size. And solution is unstable. As it is solute is not properly mixed with the solvent, so solution is unstable. Solution is unstable. So then example of suspension. What are the examples of suspension? Suspension is, you see chalk and water. Chalk particles are settled down and visible. And here muddy water, all mods are settled down at the bottom. That's a muddy water is a suspensions. So these are the examples of suspension. Then come to colloidal solution. Colloidal solutions, it is heterogeneous nature, but internally it is heterogeneous, but externally it is homogeneous. If you see, it looks like homogeneous, but it is actually it is heterogeneous, and it consists of two phases. two-phase system, that is dP and dM. What is dP? Solute is called dP, that is dispersed phase, and solvent is called dispersion medium. And this solute and solvent, that is dP and dM, are not properly mixed. That means the mixing is that not properly mixed in the solution. That's why it is what? Heterogeneous nature, and the colloidal particles not seen to naked eye, because the size particles is not visible to naked eye. Then the particle size is 10 to power minus 9 to 10 to power minus 7. That means particle size is in between 10 to power minus 9 to 10 to power minus 7. That means less than 10 to power minus 9, that is true solution, and greater than, that is greater than 10 to power minus 7, that is your suspensions, and in between 10 to power minus 9 to 10 to power minus 7, that is colloidal. Colloidal particles size is in between two particles and suspension. That's why the range is 10 to the power minus 9 meter to 10 to power minus 7 meter. Then particles cannot be seen in naked eye, but when it will be observed in the microscope, then under microscope, then this particle, the path, they follow the zigzag path. They follow the zigzag path, that is called Brownian movement. That means when you want to see the particles movement in colloidal solution with by observing the solution by microscope, then you can see the movement of particle. The movement of particle is called zigzag motion. The particle is called zigzag motion. You see the slides. Brownian movement. Observe carefully. It is studied by Robert Brown. You see the movement of colloidal particle in the solution. This type of motion is called zigzag motion. Again, I am repeating this one. You see the zigzag motion. Zigzag motion, that is what? Particles in different directions, moving in different directions. That's why it is called zigzag motion. Okay, this is zigzag motion. Random motion is called what? Brownian movement. Then another property of colloidal solution is when beam of light is passed through the colloidal solution kept in a dark, and when it is observed in the microscope, the particles, the path of the solution is observed by change in color. That is called Tyndall effect. What is Tyndall effect? That is when the light will pass through the colloidal solution, the path of the light is illuminated by different color. This illumination of colloidal solution by the exposed to light, it is called Tyndall effect. This is called scattering of light by colloidal particle. The colloidal particles scatter the light by after observing the solution, then the scattered light observed in different color. That's why it is called Tyndall effect. This Tyndall effect is due to what? Scattering of light. Scattering means it absorbs the light, then it emits the certain light in a particular color. That's what is called scattering of light. It is called Tyndall effect, generally observed by colloidal solution. You see the slide, the Tyndall effect, you observe the slides. You see how the particles, but as the first solution, a colloidal solution, the path is changes to green, that is blue color. Here the color changes to blue, and the true solution, there is no change in the color of the solution. There will be no change in the color of solution. That's why the true solution does not show Tyndall effect. Again, I am repeating this. Just you see here the colloidal solution showing the change in the path of the light. The color of the path of light is changing, that is becomes blue, but the second solution, that true solution, there is no change in the color of the light, remaining same. That's why colloidal solution shows Tyndall effect, that is scattering of light by the colloidal particle, but true solution does not show. It is only due to the difference in size. Then next, that is important, that is this Tyndall effect is observed by the scientist John Tyndall, that is Irish scientist. It is observed the Tyndall effect, and Tyndall effect is observed when you observe the light in a forest. when you go to the forest, if you observe the sunlight passing through the leaves, it is showing different color. This is example of Tyndall effect. The sky is blue, that is also example of Tyndall effect. And just you pass the solution, you see that when light is passed through that first solution, that is changing the color, and but the second solution, that is no change in color, but third solution is showing the change in color. Third solution changing color, first solution changing color, but the second solution no change in color. That means first solution is colloidal solution, second solution is third solution is a colloidal solution, but second solution not a colloidal solution, it is a true solution. So true solution does not show Tyndall effect. There is no change in the path of the light. That's why it is a true solution. This is mainly called as Tyndall effect. Then types of colloidal solution on the basis of physical state of dP and dm. As the colloidal solution is made of dP and dm, the solute is called dispersed phase and the solvent is called dispersed medium. These two components mixed forming the colloidal solution. So colloidal solution classification on the basis of physical state of dP and dm. Dispersed phase, dispersed medium, and name of the solution and examples. You see, solid in solid, it is called solid sol. Example, gemstone, different colored stone. Example of colloidal solution where solid is mixed in solid, that is called solid sol. Solid in liquid, here the dispersion medium means large amount. Solid in liquid is called sol, that is example is muddy water. Solid in gas, that is called aerosol, smoke, dust, like this. Liquid in solid is called gel, that is called cheese. Liquid in liquid, that is emulsion, that is called emulsion. Liquid in liquid, that is called emulsion. Liquid in liquid is called emulsion, that is called, example is milk. Liquid in gas, that is called aerosol of liquid. Here you see solid in gas, that is called aerosol of solid, and liquid in gas, that is called aerosol of liquid. Example is fog. Gas in solid means gas in solid, that is called solidiform. Example is pumic stone, that is gas in solid. Other examples also you can take, that is gas in solid is your bread, rubber will be examples of gas in solid, where solid is more, gas is less. Gas in liquid, that is called foam, that is called froth. Froth means formation of foams from leather. Soap solution produce leather, that is gas in liquid. So on the basis of physical state of dP and dm, there are 8 types of colloidal solution is possible. But gas in gas is not a colloidal solution, because gas in gas is a homogeneous solution. That's why it is not a colloidal solution, because all colloidal solution is heterogeneous. That's why gas in gas is not a colloidal solution. It is a homogeneous solution. It is called true solution. So these are the classification of colloidal solution on the basis of physical state of dispersed phase and dispersed medium, that is solid, liquid and gas. And a dispersion medium is always in higher amount, and dispersed phase is always in lower amount. Solid in solid means one solid is higher amount, other solid is less amount, that is called solid sol. Liquid in liquid means one liquid is higher amount, another liquid is less amount, that is called emulsion. Like this, on the basis of dispersed phase, nature of dispersed phase, colloidal solution are 8 types. Okay, this is the classification of colloidal solution. Then you have to practice these different slides, okay, and prepare the notes. Okay, thank you all.